What exerts the downward force on the top of the cube?
If the cube is not at the top surface, then the force is exerted by water above it. If it is on the top, then air pressure, which we will discuss shortly, exerts this force. Because the downward force exerted by the fluid is greater than the upward force, the force, and hence the pressure, increases as the depth of the fluid increases. So the pressure at the bottom of a container of fluid is greater than at the top. The amount of increase in pressure is given by the product of the density P, the gravitation field strength G, and the depth H, or pGh. That is, the pressure on the bottom, L bottom equals top plus pGh.
Does a compass sometimes point downward along with pointing north?
For hundreds of years, navigators using compasses noticed that on occasion, the compass pointer would try to point downward in addition to pointing north. This phenomenon, which went unexplained for several hundred years, was observed by compass maker Robert Norman. He found when flying over the poles one end of the compass would point downward. He understood that the problem was that the pointer was attracted to the pole under the plane. By making the compass rotate in the vertical direction, he made the first dip needle.
How were the details of the strong force determined?
Examining the kinds of isotopes that exist gives clues about the nature of the strong force. The most stable nucleus, helium-4, has 2 neutrons having spins in opposite directions and 2 protons also having spins in opposite directions. A majority of non-radioactive isotopes have even numbers of neutrons and even number of protons, allowing them to form pairs with opposite spins. Most of the other isotopes have either an even number of protons and an odd number of neutrons or the opposite. Isotopes with both an odd number of protons and neutrons are extremely rare. So, the strength of the strong force clearly depends on the spins of the nucleons. The mass of a nucleus is less than the sum of the masses of the protons plus the sum of masses of the neutrons. The larger the mass difference, the stronger the forces holding the nucleus together and the more energy needed to pull the nucleus apart. Studies of the mass of the nuclei can thus be used to gain further insight into the strong force. Maria Geppert-Meyer, 1906–1972, was a German-born American physicist who explained why nuclei with certain numbers of protons and or neutrons, called magic numbers, were extremely stable. Her theory showed that the nuclear force depended on both the spin of the nucleon and its orbital angular momentum. The magic numbers are 2, 8, 20, 28, 50, 82, and 126. Thus helium-4, the most stable nucleus, has a magic number of protons and a magic number of neutrons, and so is called doubly magic. Oxygen 16, calcium 40, and calcium 48, and lead 208, which is the heaviest stable nuclide, are also doubly magic. But, are all nuclei stable? What rays do radioactive materials emit? Among the scientists who explored radioactivity immediately after Becquerel's discovery was Ernst Rutherford. Then at McGill University in Montreal, Canada. He and Frederick Soddy found that uranium and thorium emitted two different kinds of rays. One could be stopped by paper, the other required metal about a centimeter thick. Rutherford named them alpha and beta rays after the first two letters in the Greek alphabet. In 1907 he named the even more penetrating rays produced by radium gamma rays. In 1900 Pierre, 1859 to 1906, and Marie Curie, 1867 to 1934. Using an electroscope, found that beta rays are negative particles. Becquerel used the same kind of apparatus J. Thomson. 1856 to 1940, had used, see the chapter What is the World Made of? To measure the ratio of mass to charge of an electron to determine that betas typically travel at about half the speed of light and are identical to electrons. In late 1907 Rutherford demonstrated that alpha rays were helium atoms with the two electrons removed. He had not yet discovered the nucleus. Today we say that an alpha particle is the helium-4 nucleus. Gamma rays were later found to be very high-energy photons.
What causes red eye in photographs?
Red eye occurs when a flash is used because there is not enough light for a good exposure. Under normal conditions, in order for enough light to enter the eye, the pupil dilates. But when a flash is fired, the pupils are not expecting the bright light and do not have a chance to constrict. As a result, a large amount of light enters the eye and reflects off the blood vessels that supply the retina in the back of the eye. The redness on the pupil is actually the reflection off these blood vessels captured by the camera. Camera lenses are similar to human eyes in that both have lenses that focus images onto a surface. But camera lenses are not flexible like an eye lens.
What is a scalar quantity?
A quantity that has only magnitude, size.
What is a VAD de Graaff generator?
Device using static electricity to produce very large potential differences.
What is an image?
Suppose light falls on your face. Light is reflected diffusely from this surface. That is, it is reflected into a wide variety of directions. Consider a very tiny object, like the end of an eyelash. Light from that point will leave in many directions. That point is called an object. An optical device can cause the light rays from the object to converge again to a single point. That point is called the image.
What are the limits of the Bohr model?
Today's model is totally different from Bohr's 1913 model. Bohr's model could explain only the spectra of hydrogen and helium from which an electron was removed. With some modifications, it could also explain the spectra of the alkalis like lithium. From 1913 through 1926, physicists tried to extend the model, with some successes. But the lack of a physics-based explanation of the postulates led to research aimed at a model that was not based on classical ideas like Bohr's. One of the first steps was taken by the young German physicist Werner Heisenberg, 1901 to 1976.
What units are used to describe speed?
In the English units used in the United States, speeds are usually given in feet per second or miles per hour. In the metric system, meters per second or kilometers per hour are more common. Here are some typical speeds in the four systems of measurement.
What is a Large Hadron Collider, LHC?
Very high synchrotron at CERN near Geneva, Switzerland.
What is a torque, T?
Equivalent of force for rotational motion. If forces is at a right angle to the radius, then torque equals the force times the distance from the axis of rotation.
What is a torsional wave?
Material is not only displaced vertically, but also twists in a wave-like fashion.
What is perpetual motion?
Forbidden by the second law of thermodynamics.
What is a sonic boom?
A sonic boom occurs when an object travels faster than the speed of sound. The boom itself is caused by an object, such as a supersonic airplane. traveling faster than the sound waves themselves can travel. The sound waves pile up on one another, creating a shock wave that travels through the atmosphere, resulting in a boom when it strikes a person's ears. A sonic boom is not a momentary event that occurs as the plane breaks the sound barrier. Rather, it is a continuous sound caused by a plane as it travels at such a speed. But the shock wave travels with the plane, so we hear it only when the plane is in one location. Supersonic planes, such as this F-15 fighter jet, can go beyond Mach 1. When they do, they generate a sonic boom caused by sound waves piling up and creating a shock wave. All objects that exceed the speed of sound create sonic booms. For example, missiles and bullets, which travel faster than the sound barrier, produce sonic booms as they move through the atmosphere. The shock wave created by an F-15 fighter plane, for instance, is visible.
What is a gold alloys?
"24-karat gold is pure gold. 18-karat gold has 18 parts gold and 6 parts other metals. 10-karat gold has 10 parts gold and 14 parts other metals.
What happens to the buoyancy of the ship when cargo and passengers are added?
When cargo and passengers are added to a ship, its weight increases. As the ship's weight increases, it sinks further into the water, displacing a greater weight of water. If it sinks so far that water can spill into the ship, increasing its weight even more, the ship sinks to the bottom of the water. The amount the ship sinks in the water as a result of cargo and passengers can be critical for navigation and maneuverability. Large cargo and cruise ships have numbers on the bow of the ship that indicate how far the distance is between the water line and the bottom of the ship. This distance is called the ship's draft. If the ship has a 6 km, 20-foot, draft and the water is only 5.5 km, 18 feet, deep, cargo and passengers must be unloaded to allow the ship to rise.
What happens to a balloon when it is submerged in water?
When an air-filled balloon is placed underwater, the water, which has higher pressure than the air, exerts a force on all sides of the balloon. The pressure from the water causes the air to compress inside the balloon. The deeper the balloon is taken into the water, the greater the pressure, and therefore, the smaller the balloon will become. The pressure from the water will compress the balloon until the air pressure within the balloon can supply an equal amount of force against the water.
How do the police use the Doppler effect in radar guns?
The police use the Doppler effect when checking for speeding vehicles. A radar gun sends out radar waves at a particular frequency. As the radar wave hits a vehicle, the wave reflects back toward the radar gun at a different frequency. The frequency of the reflected wave depends upon the direction and speed of the vehicle. The faster the speed, the greater the frequency change. The radar gun determines the speed of the vehicle by measuring the difference between the emitted frequency and the reflected frequency and computing the speed from that measurement.
How does air drag affect the motion of dropped objects?
Air drag adds a second force exerted on the object that is in the direction opposite its motion. The net force is the difference between the downward force of gravity and the upward force of air. As was discussed above, the force of the air increases as the speed increases. Therefore, as the object falls and gains speed, the upward force increases. At some time it will equal the downward force and there will be no net force on the object. So, according to Newton's first law, the object's speed will now become constant. This constant velocity is called the terminal velocity.
What are the different frequencies of radio waves and microwaves that allow for communication?
The table below shows the regions of the electromagnetic spectrum and their uses. The unit for frequency is Hertz, Hertz. Hertz is the name for the number of oscillations or cycles per second of a wave. The letters kilohertz mean 1000 Hertz, megahertz a million Hertz, and GHz 1000 million or a billion Hertz or cycles per second.
What is a nucleon?
Generic name of protons and neutrons.
What is the Rydberg formula?
Wavelength of the emitted radiation from hydrogen atom is given by 1/x equals r, 1/m2, 1/n2. The numbers m and n are the quantum numbers of the two energy levels. For example, the red line would be m equals 2, n equals 3. The Rydberg constant r equals 0.01097 nm1.
How are magnetic materials used in computers?
Magnets are used in the compact motors that turn the discs in the CD or DVD drive and that move the laser that reads the disc to the correct position. Motors rotate the discs in a hard drive. The arm on which the read/write head is mounted is rotated to the correct portion of the hard drive disk has a coil of wire on it in a magnetic field. When there is a current through the wire, the force moves the arm to the correct position. The disc itself is often made of aluminum coated with an extremely thin 10 to 20 nanometers film of magnetic material that is divided into submicrometer thick regions that are perpendicular to the surface of the disc. Each region is magnetized one way to represent a 1 and another way to represent at 0. A tiny coil in the reed/right head carries the current that magnetizes the regions.
Why do you need two connections at the ground potential?
Because when the appliance plugged in draws current, there is current through both the black and white wires. Each wire has resistance, so there will be a voltage drop across the white wire, and it will be above ground potential at the outlet. While this voltage will be small, it could be dangerous. The green wire, which carries no current, will remain at ground. It can be connected to the metal case of the appliance, assuring that the case will remain at ground potential. When installing an electrical outlet, note that the green wire. Okay, you can't tell in this black and white photo, but it is there. Is the grounding wire, which must be attached to the grounding contact on the outlet.
What is angular momentum?
Equal to the product of its moment of inertia and its angular velocity.
What is Kepler's second law?
In equal times planets sweep out equal areas.
What is drag?
Drag is a force that opposes the motion of an object through a fluid. An object is often said to be aerodynamic when its drag forces are kept to a minimum. There are two types of drag on an airplane, parasitic and induced. Parasitic drag is the force when an airplane wing, automobile, or any other object moves through a fluid. The amount of drag depends on the density of the fluid, the square of the speed of the object, the cross-sectional area of the object, and its shape. A large fuselage, like that of a 747, has more drag than a small fighter airplane. A teardrop-shaped object has less drag than a rectangular block. A parachute is designed to have a high drag. Induced drag is a consequence of the lift generated by the wing. It is a function of the angle of attack of the wing. The lower the angle of attack, the smaller the induced drag. It occurs at the outer edge of the wing where the downward motion of the air caused by the wing meets the undisturbed air next to it. Induced drag causes vortices. The spiral motion of air that can be extremely dangerous to planes flying behind or below. Induced drag can be reduced by putting small, tilted surfaces on the wing tips.
What is special relativity?
Study of the descriptions and explanations of the motion of objects moving near the speed of light.
How does a Leyden jar work?
A Leyden jar is an insulating container with conductors on the inner and outer surfaces. When charging the Leyden jar, the source of charge is connected to a rod, touching the inner conductor while the outer conductor is connected to ground. The inner and outer conductors become oppositely charged. It takes energy to move additional charges to the jar as the charges overcome the repulsive forces of the charges already on the conductors. The jar stores this electrical energy. If the inner and outer conductors are connected by a wire, the charges flow and make the two conductors neutral again. The modern capacitor is an updated version of the Leyden jar consisting of two conductors and an insulator.
How is Earth's magnetic field oriented?
Because opposite poles attract. The north pole of a hanging magnet or compass must point toward a south pole. So, the south pole of Earth's magnet must be near the north geographic pole. The poles are actually far below Earth's surface, so Earth's field is not parallel to its surface.
How is the friction between two surfaces characterized?
In most cases, the frictional force is proportional to the force pushing the surfaces together, N. This proportionality is usually written as friction equals μ*n. The Greek letter U, mu, is called the coefficient of friction. It is important to remember that the two forces, friction and N, are not in the same direction.
What is physical optics?
Division of optics that depends on the wave nature of light, polarization, diffraction, interference, and the spectral analysis of light waves.
What is the law of reflection?
Angle of incident light is equal to angle of reflected light.
What did Einstein do to win worldwide fame?
By 1914 Einstein's accomplishments were well accepted by physicists and he was appointed professor at the University of Berlin and made a member of the Prussian Academy of Sciences. Einstein published the general theory of relativity in 1916. Among its predictions was that light from a star would not always travel in a straight line, but would bend if it passed close to a massive body like the Sun. He predicted a bending twice as large as Newton's theory predicted. During a 1919 solar eclipse these theories were tested and Einstein's prediction was shown to be correct. The result was publicized by the most important newspapers in England and the United States, and Einstein became a world figure. In 1921 he won the Nobel Prize in Physics as a result of his work on the photoelectric effect.
How are refrigerator magnets made?
Examine a refrigerator magnet. It is flexible, feels like rubber, and only one surface is attracted to metals. It doesn't stick to a stainless steel door unless the stainless has been coated with steel. It's made of rubber that has been impregnated with ferrite particles and magnetized. Small pieces, each a dipole, are then pressed together under heat to bond them into one thin sheet that can be cut, folded, and bonded to other sheets.
Which car has the larger acceleration?
Both have the same change in speed. But the sports car requires less time to make the change, so it has the larger acceleration. Like velocity, acceleration is a vector. That is, it includes both magnitude and direction. In speeding up, in which the change in velocity is positive, acceleration is a positive quantity. If the object is slowing down, then the acceleration is negative. If, however, the object is going in the negative direction, for example, a car going in reverse then speeding up is a negative quantity because the final velocity is more negative than the initial velocity. Physicists do not use the term deceleration. Whether positive or negative, speeding up or slowing down, the term acceleration is always used. The table below shows some typical accelerations in a variety of units. The rightmost column, labeled G, compares the acceleration to that of an object falling in Earth's gravitational field. This ratio is frequently used in both everyday and scientific writing.
What is a thermograph?
Picture that shows the temperature of every location in the picture. Thermometer device to measure temperature.
How does Earth's atmosphere affect the apparent locations at which we see stars?
The light from stars refracts slightly as it enters Earth's atmosphere. Refraction is largest nearest the horizon. As a result, the true position of the stars is a bit off from where we observe them. Refraction of light from the sun results in sunrise being slightly earlier than it would be without the atmospheric refraction, and sunset is slightly later. Refraction also distorts our view of the sun and moon when they are very close to the horizon.
Where are fiber optics used today?
The transmission of light information through optical fibers has had a huge impact on the technological world. The medical field has benefited greatly from the use of flexible fiber optic bundles that enable the viewing of areas of the body that would otherwise be inaccessible. Communications is probably the field that is benefiting the most from the advent of fiber optic technology. Long-distance telephone, computer, and television signals use fiber optic cables. Some systems even use fiber optics to transmit information directly to the home or business. Fiber optics can transmit large amounts of data at high speeds, permitting hundreds of television channels, very high-speed internet connections, and telephone conversations to be sent and received at the same time.
What is antimatter?
In 1932, Carl Anderson, 1905 to 1991, was studying particles produced when cosmic rays struck lead sheets in a cloud chamber that was in a magnetic field. He found low-mass particles that curved the opposite direction from electrons, showing that they had positive charge. He later confirmed the existence of these particles by using a laboratory source of high-energy gamma rays. This positive electron was named the positron and was the first form of antimatter found. Anderson shared the 1936 Nobel Prize for his discovery. When a gamma ray with sufficient energy strikes matter, it can produce an electron-positron pair. Energy is converted into particles with mass. The minimal amount of gamma ray energy needed is given by Einstein's famous equation. A gamma equals electron 2 plus positron 2. The unchanged arc gamma produces a negatively charged electron and a positively charged positron, so electric charge is conserved. Positrons are also emitted in radioactive decay of isotopes that have a deficit of neutrons. For example, stable carbon exists as 12C or 13C, 6 protons and either 6 or 7 neutrons. As was discussed above, 14C decays by emitting an electron. One of the neutrons changes to a proton with the emission of the electron and antineutrino. On the other hand, 11C, with only 5 neutrons, is a positron emitter. One of the protons changes to a neutron with the emission of a positron and a neutrino. When a positron strikes matter, the positron and an electron annihilate each other, producing 2 or 3 gammas. Particles with mass are converted to energy.
Where would you put the material to be cut if more force is needed to make the cut?
You would put it nearer the pivot. On the other hand, if the material is easily cut, cutting near the tip of the blades provides enough force and speeds up the cutting.
What is an alloy?
A metal that is a mix of two or more different metals.
What is the atmospheric pressure?
Earth's atmosphere extends approximately 100 kilometers, 328,000 feet above the ground, but it gets less and less dense as the altitude increases. If the density were constant, then the atmosphere would be about 8 kilometers high, 26,246 feet. Close to the height of Mt. Everest. Some 63% of the atmosphere is below that height. The amount of force on an area of 1 square meter is about 101,300 newtons. That is, the pressure is 101.3 kPa. Atmospheric pressure varies with temperature and other conditions. Our weather is mostly influenced by high and low pressure regions, which can deviate by about 5% from normal. The pressure decreases as your altitude increases because the amount of air above you creating the pressure is smaller. At an altitude of 3 kilometers, 10,000 feet above sea level, the atmospheric pressure is about 70% of what it is at sea level. At 100 kilometers it is 3/millionths of the sea level pressure.
On what does the terminal velocity depend?
Air drag depends on the density of the air, the size, velocity, and the shape of the object. Therefore the terminal velocity will depend on all of these, plus the mass. You can test to see if the air drag depends on the velocity, or the velocity squared, by doing a simple experiment. You'll need only 5 filters for a drip coffee maker. The filters must be cup-shaped. If the drag depends on velocity, then the terminal velocity will be given by kV equals mg, where k is some constant. Thus v will be proportional to m. On the other hand, if the drag depends on the square of the velocity, then the terminal velocity will be given by kv2 equals mg, so v will be proportional to the square root of the mass. The experiment depends on the fact that you can compare two velocities by dropping two objects at the same time, allowing them to fall different distances, and observing whether they hit the ground at the same time. If the drag depends on velocity, then doubling the mass will double the velocity. Stack 2 filters and hold them above your head. Hold a single filter in the other hand half that distance above the ground. Drop them at the same time and see if they hit the ground together. As they should if 2 filters fall twice as far in the same time. What did you observe? You probably found that they didn't hit the ground at the same time. Now add 2 more filters so you have a total of 4. The square root of 4 is 2, so if the drag depends on the square of the velocity, the 4 filters will now fall twice as fast as the single filter. Try it. Do they hit the ground at the same time? Air drag is more complicated than this simple experiment suggests. At slow speeds the drag constant, k, is larger than at higher speeds. Many studies have been done on the air drag of tennis balls, baseballs, and soccer balls. The fuzz, stitches, and panels have a strong effect on air drag. As anyone who has tried to hit a knuckleball will testify.
What official titles did Newton receive?
Newton was extremely well respected in his time. Although he was known for being nasty and rude to his contemporaries, Newton became Lucasian Professor of Mathematics at Cambridge in the late 1660s, President of the Royal Society of London in 1703, and the first scientist ever knighted. In 1705, he was famous as the master of the mint, where he introduced coins that had defined edges so that people couldn't cut off small pieces of the silver from which the coins were made. He is buried in Westminster Abbey in London.
What is a rainbow?
Spectrum of light formed when sunlight interacts with water droplets. Angle between entering and leaving is 40 degrees for blue light, 42 degrees for red.
What are brittle materials?
Usually break when under tension rather than compression.
How much energy is contained in a lightning flash?
An average lightning bolt transfers about 5 coulombs of charge and about 500 million joules of energy. The transfer takes about 30 millionth of a second, and the electrical power in a bolt can be as large as 1000 billion watts.
What did Newton add to the knowledge of sound media?
Although he mainly concentrated on classical mechanics and the principles of geometric optics. Isaac Newton, 1642 to 1727, did make several important discoveries in the field of sound. His major contribution was his work on sound wave propagation. He showed that the velocity of sound through any medium depended upon the characteristics of that particular medium. Specifically, Newton demonstrated that the elasticity and the density of the medium determined how fast a sound wave would travel. Because Newton worked before the field of thermal physics was developed, his theory has errors, but they are not significant to the calculation of sound speed.
What are examples of levers?
The first-class lever shown above has a mechanical advantage greater than 1.
What is subtractive color mixing?
As opposed to the mixing of light, additive color mixing. Subtractive color mixing occurs only when combining dyes, pigments, or other objects that absorb and reflect light. For example, you could shine white light through two colored filters or gels. Or, you can reflect light from colored surfaces. If you shine white light on a blue wall, the wall absorbs red and green but not blue. So if we know what colors are reflected, we know the color of the object. The primary pigments or dyes are magenta, which reflects blue and red light but absorbs green, cyan, which reflects blue and green but absorbs red, and yellow, which reflects red and green but absorbs blue. These are the same colors as the secondary colors obtained when mixing light. Note that if we combine magenta, cyan, and yellow, the red, green, and blue are all removed, leaving nothing, that is, black. Blue is light in the range of 400 to 500 nanometers. Green is roughly 500 to 560 nanometers. Yellow is 560 to 590 nanometers, orange 590 to 620 nanometers, and red beyond 620 nanometers. It may seem surprising that yellow filter transmits green, yellow, and red. But the eye is not very sensitive to red in comparison to green and yellow. That's the same reason that the transmission of the blue and indigo filters beyond 660 nanometers does not impact what the eye sees. Finally, note that purple is a mixture of blue and red.
What's a watt?
Suppose you climb the stairs to the second floor. Whether you run or walk, because you have gone up the same distance, the increase in the gravitational field energy will be the same. The difference is the rate at which the energy has changed. The rate, the change in energy divided by the time taken, is called power. Power is measured in the unit called the watt. 1 watt, W, is 1 joule, J, per second, S. A kilowatt is 1000 watts or 1000 joules per second. Scottish inventor James Watt came up with the term horsepower, which is equal to 746 watts. The amount of energy it takes an average horse to pull 33,000 pounds of coal 1 foot in 1 minute. Automobiles can accelerate from 0 to 60 miles per hour, but the more powerful ones can do it in 6 seconds or less, while ones with less powerful engines may take more than 10 seconds.
What is general relativity?
Study of the descriptions and explanations of the causes and effects of gravity.
What is a drag?
Force that opposes the motion of an object through a fluid.
What is a solid?
State of matter. Solids retain their shape because strong forces hold the atoms in their places.
Why aren't the Van Allen belts present around the North and South poles?
At the equator, the magnetic field is parallel to the ground and the electrons and protons from the solar wind can become trapped around the field lines. At the poles, however, the magnetic field strengthens, the lines become closer together, and forces on the particles push them back toward the equator. Some of the most energetic particles are able to penetrate the atmosphere where they interact with oxygen and nitrogen atoms, producing the natural light shows that are called auroras.
What is the name of the supporting force from the chair?
Another term for a supporting force is normal force. The normal force is always directed perpendicularly out of the surface. The normal force of a chair is straight up if the chair is on a level surface, while the normal force of an incline would be perpendicular to the surface of the incline, and not perfectly vertical. The term normal was derived from the geometrical name for a 90 degrees angle and is not the opposite of abnormal.
What is neutrino oscillation?
Change of neutrinos from one flavor to another, that is a proposed solution to deficit of neutrinos emitted by sun.
Can sound take the ocean's temperature?
Between 1995 and 1999 the ATOC, or Acoustical Thermometry of Ocean Climate, experiments measured the speed of sound in the Pacific Ocean. Sound sources at 75 Hz were located off the California coast and near the island of Kauai in Hawaii. Detectors were positioned at various depths off the coast of Alaska, near the Big Island of Hawaii, near Kamchatka, Russia, and New Zealand. The speed of sound compared to the speed of light can be observed at a baseball game. A spectator sitting in the outfield bleachers sees the batter hit a ball before she hears the crack of the bat.
Why shouldn't metal objects be placed inside microwave ovens?
Manufacturers caution consumers about placing metal containers and aluminium foil inside microwave ovens for two main reasons. The first reason is that metal and aluminium may impede cooking. Microwaves warm food by transmitting energy to water and fat molecules within the food. If food is placed under aluminium foil or in a metal container, the microwaves will be reflected from the metal and won't be able to reach the water molecules and cook the food. The second reason for not placing metal objects inside a microwave oven is for the safety of the microwave oven itself. Metal acts as a mirror to microwaves. If too much metal is placed in the oven, the microwaves will bounce around the oven in waves that can damage the magnetron that produces the microwaves. If the metal is the correct size, it can act as a microwave receiver, and the induced voltages can produce sparks that can ignite the food.
What were some of Niels Bohr's accomplishments as an exemplary physicist and citizen?
Bohr returned to the University of Copenhagen as a professor of physics in 1921. With the help of the government and the Carlsberg Beer Foundation, he established the Institute of Theoretical Physics. Bohr's institute attracted all the major theoretical physicists from around the world for short visits or extended appointments. When the Germans occupied Denmark, Bohr made a daring escape. First to Sweden, then England, then the United States. He was a consultant in the atomic bomb development effort, but after the war he tried to get President Harry Truman. 1884 to 1972, and British leader Winston Churchill, 1874 to 1965, to agree to share the secrets of the bomb with all countries, including the Soviet Union. They both rejected Bohr's proposal. But after the Soviets developed the bomb, Bohr's ideas helped found the United Nations International Atomic Energy Agency. Until his death in 1962 he worked to reduce the threat of a nuclear war. In the centenary of his birth, Denmark issued a postal stamp showing Bohr and his wife, Margrethe.
What is a coulomb?
equal to the charge of 6.24 x 1018 electrons, negative, or protons, positive.
What is a qubit?
Qubit is short for quantum bit, the basic piece of information for a quantum computer. A qubit can be the state of an atom, ion, photon, or an electron. As was the case of the polarization of the two gammas, the qubit doesn't have a value of 0 or 1, but is in a state that is a superposition of 0 and 1, so it can have any value between those two numbers. If you try to measure the value of the qubit, you will get either 0 or 1. So it will act like a bit in a normal computer. The trick is to use one of two entangled photons, or atoms, to determine the qubit state without collapsing it into either 0 or 1. Quantum computers are by nature parallel machines that can work on many problems at once. At this time, computers with 12 qubits have been demonstrated. So there is a long way to go before such a device is practical. Still, progress is being made. A company has demonstrated a way of using the kind of chip lasers used in CD players to create entangled photons, greatly reducing the size, complexity, and cost of a quantum computer.
What is a Faraday cage?
A Faraday cage, named after British physicist Michael Faraday, is a cage. Metal grating, or metallic box that can shield electrical charge. Charges gather on the outer shell of the cage because they are repelled by one another and can be further from each other if they are on the outside of the cage. This results in no charge within the Faraday cage. The metal sphere of a Van de Graaff generator is a Faraday cage. Cars and airplanes can be Faraday cages as well, and may provide some protection from lightning during an electrical storm.
What is resonance?
Occurs when an external oscillating force is exerted on an object that can vibrate. When the frequency of the external force equals the natural frequency.
What is a second, S?
The time it takes for 9,192,631,770 periods of microwave radiation that result from the transfer of the cesium-133 atom between lower energy and higher energy states.
What materials are used for static structures?
The first materials used were made of stone. especially stones like flint that could be chipped to make sharp edges and points. Ancient peoples discovered metals, either in pure form, or in ore, that is mixed with non-metals. Copper, tin, gold, and iron were known before 2000 BCE. Copper, tin, and gold are very soft and not very useful as tools or weapons. A method of hardening metals is to mix two or more different metals forming what is called an alloy. Bronze is made by adding tin to copper and was known by about 4000 BCE. In what is now Iran and Iraq, the tin came from southern England. Bronze is a hard metal that can be melted and cast in various shapes, including statues. Today bronze is used for bells and cymbals. Not much later methods were found to convert iron ore, which is iron mixed with either oxygen or sulfur, to pure iron using a charcoal fire. Iron replaced bronze as a material for tools and weapons because it was cheaper and didn't require long trade routes to obtain the tin. To keep iron from being brittle, the carbon must be removed. If the iron is heated to red heat and then hammered, the carbon is forced to the surface where it can be removed. The result is steel that contains less than about 1% carbon. Steel is a versatile alloy of iron and carbon because additional materials can be added to change its properties. Very hard steel, called tool steel, contains tungsten, molybdenum, and chromium, among other minor additions. Its hardness can be changed by heating it and then cooling it very quickly by quenching it in water or other liquids. Stainless steel used in knives, forks, and spoons has 18% chromium and 10% nickel. Other stainless steels use different amounts of these two metals as well as molybdenum and magnesium. Stainless steel does not rust, but isn't as hard as tool steel. Pewter is a tin alloy that was developed in England for plates and cups. It adds copper, bismuth, and antimony to tin. Originally lead was used, but because it is poisonous, it is no longer found in pewter. Brass is typically 80% to 90% copper with zinc added. Actually, brass was made before metallic zinc was isolated. The zinc or calamine was melted with copper. Brass is used as a decorative metal as well as in bullet casings. If aluminium and tin are added, it is resistant to corrosion by seawater. Gold is another very soft metal. It can be made harder by adding copper and silver in equal quantities. Gold alloys are measured in carats. 24-karat gold is pure gold, while 18-karat gold has 18 parts gold and 6 parts other metals. 10-karat gold has 10 parts gold and 14 parts other metals. Titanium is used in many alloys today because it is lightweight and corrosion resistant. Many alloys of both metals and nonmetals are used in electronics. Some LED lamps contain the metals gallium and aluminium and the nonmetal arsenic.
What are force carriers?
The photon is called the force carrier for the electromagnetic interaction. That means that, for example, the attractive force between two oppositely charged objects is described mathematically not by an electric field, but by an exchange of invisible photons. The photon has neither mass nor charge, but does have angular momentum. The gluon carries the color force which, in combination with quarks, creates the strong force. The gluon also has neither mass nor charge. The weak nuclear force is carried by the massive W+, W', and Z degree particles. Gravity is carried by a massless particle called the graviton.
What is the speed of sound?
In air about 340 m/s or 760 miles per hour, at 20 degrees Celsius. Increases by 0.6 meters per second for every degree Celsius increase in temperature. V equals 331 m/s, 1 plus 0.6 T, where T is measured in Celsius.
What is a second-class lever?
Simple machine with effort force exerted at one end or bar. The input force applied at the other end, and the pivot between the two. Ma less than, equal to, or greater than 1.
What is a cornea?
A transparent membrane that contains the fluid in the eye.
What is a period?
The time it takes for an oscillating object or wave to complete one full vibration. The inverse of the frequency.
What is the second law of thermodynamics?
In the early 1800s, many scientists and engineers worked to improve the efficiency of steam engines. The French military engineer and physicist Sidi Carnot, 1796 to 1832, tried to answer two questions. Is there any limit to the amount of work available from a heat source? And can you increase the efficiency by replacing steam with another fluid or gas? Carnot wrote a book in 1824 called Reflections on the Motive Power of Fire that was aimed at a popular audience, using a minimum of mathematics. The most important part of the book was the presentation of an idealized engine. This engine could be used to understand the ideas that can be applied to all heat engines. A heat engine is a device that converts heat into work in a cyclical process. That is, the engine periodically returns to its starting point. A steam engine, gasoline, or diesel power automobile engine are all heat engines where the pistons return to their starting positions. A rocket is not a cyclic heat engine. A diagram of Carnot's simplified model allowed him to give answers to his two questions. He found that the efficiency, that is, the work output divided by the heat input, depended only on the temperatures at which heat enters and leaves the system, or efficiency equals, thought, cold/thought. It doesn't depend on the fluid or gas used in the engine. Real engines would have lower efficiencies, but no engine could have a higher efficiency. A simplified version of the second law according to Carnot is that it is impossible to convert heat completely into work in a cyclic heat engine. There is always some heat output. Note that the first law would allow a heat engine to have no heat output. The heat input would equal the work done. The second law can be shown in the diagram below, where the input heat is taken from a reservoir that maintains a constant high temperature and the output goes to a second reservoir at a constant low temperature. For example, a steam turbine gets its heat from high temperature steam and puts its output heat into a much colder lake or river. This turbine plant in California uses natural gas to heat water into steam that then produces energy in the turbines that generate electricity. Not all the energy from the natural gas can be converted to electricity, and lost energy escapes as heat. Carnot's model engine is reversible. That is, it can be run backwards, which is impossible for a real engine. Thus all real engines are less efficient than the ideal one. Friction also lowers the efficiency of real engines. The second law, according to Carnot, means that there is no such thing as a perpetual motion machine. Although such a machine could obey the law of conservation of energy, the heat it puts out means that the machine would eventually stop. Carnot died in a cholera epidemic at age 36. Because people were concerned with the transmission of this deadly disease. All his papers and books were buried with him after his death. Thus only a few of his works have survived. Despite the limitations of Carnot's model, his work inspired Rudolf Diesel, 1858 to 1913, to design the engine named after him to achieve higher efficiencies than steam engines. So, Carnot's book was important to the design of practical engines. A second version of the second law can be stated as heat doesn't flow from cold to hot without work input. For example, a refrigerator removes heat from the food at a low temperature and outputs heat from the coils in the bottom or back of the refrigerator. It will not move the heat from cold to hot, however, without a motor doing work on the circulating gas.
What is the evidence that neutrinos have mass?
The number of neutrinos detected from the Sun is only a fraction of what should be detected if our understanding of the nuclear reactions in the Sun is correct. A proposed solution to this problem is that neutrinos change from one flavor to another on their travel from the Sun to Earth. This phenomenon is called neutrino oscillation. It can only occur if the neutrinos have a small mass. Most experiments that support neutrino oscillation measure the lack of neutrinos of one flavor that they interpret as an oscillation into an undetected flavor. Recently an experiment has detected tau neutrinos in a muon neutrino beam from an accelerator at CERN and a detector 732 kilometers away, in the Gran Sasso tunnel in Italy. This flavor change supports neutrino oscillation.